Alrighty, so 4.3, solving quadratic equations using the quadratic formula. The quadratic formula, probably one of the most infamous formulas in all of math. Something that most people say in their heads when they're sleeping at night. And the quadratic formula is this equation right here, where x equals, and why is it x? Because generally speaking, we are solving for x, right? Like we are giving you a function, f of x, which is in terms of x. So what the quadratic formula spits out is when you are solving, meaning you are finding the x-intercepts or the solutions or the zeros, all right? The quadratic formula essentially is a formula that will give you these values. So meaning that if you applied your quadratic formula, and let's say you got something like a value of 2, okay? That means you would have a x-intercept, and say you only had one value, you'd have a x-intercept right here, right there, at 2, 0. Okay, so that's what the quadratic formula is spitting out. It's your zeros, your solutions. Now, let's read this blurb inside this. The roots are the zeros or x-intercepts of the equation. The values of a, b, and c determine whether a quadratic equation has 1, 2, or 0 real roots. Because sometimes a quadratic equation doesn't, sometimes you can't even factor or solve because you have a parabola that never touches the x-axis. So I want to start this lesson by saying the quadratic formula, or not start essentially, but I want to say the quadratic formula can always work. You can always use it. Whenever you're dealing with quadratics, you are always able to use the quadratic formula, right? You might not get a solution, okay, because there might not be a solution. There might be 0 solutions, but you can always apply it. But the key thing is, there might be more efficient ways of solving, all right? So, yes, you can use it, but if you're running out of time on an assessment, all right, it's not the best method to use, right? It's like thinking like a power tool versus a handsaw. Yeah, you can cut a tree down with a handsaw, but is it the best tool for the job? Probably not. You might want to use a chainsaw or, I don't know, like a big machine or something. So, let's look at example 1. Solve the following equation. And in this case, actually, it's telling us what to say. It's telling us to factor, okay? So let's factor this. So at this point, we should be familiar with factoring. So first thing we need to do is we need to get all the terms over to one side. So let's bring this 7x over and this 15 over so that it becomes 5x squared minus 3x. Bringing the 7x over makes it negative 7x. Bringing the 15 over makes it minus 15. And the reason we brought those over is because now we can set it equal to 0. And that's what solving means. We're solving for x values when this is 0. So we can collect our like terms right here. So this is 5x squared minus 10x minus 15. Before we start factoring, look and see that you have here 5 that can go into all of these terms here. So factor that 5 out. X squared minus 2x minus 3. And now we have a simple trinomial where we need two numbers that multiply to give you negative 3 and add up to negative 2. So in this case, this would be minus 3 and plus 1. Because these two numbers multiplied give you this, and those same two numbers add up to give you that. So solving this, now I take my first factor, I set this to 0, so x minus 3 is 0, so then x equals 3. That is one solution. And then right here, x plus 1 is 0, so then x equals negative 1. So you have two solutions. So your solutions are, so therefore, x equals 3, comma, x equals negative 1 are the solutions. or the roots. Okay, solve the following equation by using the quadratic formula. So the quadratic formula, well, in this case, the variable we are solving for is x. So it will be x equals negative b plus or minus b squared minus 4ac all over 2a. So using the quadratic formula, you need your quadratic in standard form because this is your a, this is your b, and this is your c. So plug those values in. Here we get x equals negative. In our case, we have b being a negative 4. So minus 4. Keep in mind it's negative 4. Then you do plus or minus. Then you have b squared. So minus 4. Square that number. Minus 4 times your a. In this case, wow, there's lots of 4's here. Minus 4 times 4 times 1, and our AC value is 1. There you go. All over 2 times your A. And keep in mind, the whole, sorry, not A, 4. The whole thing is being divided by that 2 times 4. So now let's clean this up, okay? So you have x equals, well, negative times negative 4 just becomes 4 out front, plus or minus, well, under the square root, make that a nicer square root. Oh. So under the square root, that negative 4 squared is 16, minus 4 times 1 is minus 16, all over 8. Well, x equals 4 plus or minus the square root of 0 over 8. Well, square root of 0 is 0, so it's x equals 4 plus or minus 0, so nothing, over 8. So then you actually only got one solution. X equals 1/2. So solving this quadratic means you have a parabola where at x of 1/2, at 1/2 here, you only have one solution. So the parabola actually looks like this, where it only touches the x-axis right at the vertex. Okay, so solve. So notice how long that took. That was a complicated formula. So we can solve these probably much faster if we can try different methods, but not always. We might have to use the quadratic formula if we can't factor. So let's look at this. We are solving. So once again, all of these problems are saying set one side equal to 0. So let's bring this first one, this negative 3x, over. So that becomes x squared plus 3x equaling 0. So factor out your GCF. Our GCF in this case is x. x plus 3 equals 0. Well, there you go. That's actually already factored. So now we can solve it. So this is the one that throws everybody off. Technically that x in front is in a bracket. So like you do everything else, you take one of your factors, in this case this factor just being x, you set that bracket to 0. Well, setting it to 0, just that is your solution. So x equals 0 is one solution. Take your other one, x plus 3, set that to 0, so x equals minus 3. There you go. That's your other solution. So that quadratic there had two solutions, and factoring was the way to go. Much faster. Okay. So take a second and think, what would you do here? What type of quadratic are we given? Well, This one is in vertex form. So when you're given a quadratic in vertex form, it's very easy to solve for the zeros. All right, all you do is take the negative 9, bring it over, so you get x minus 2, square that, equal to 9. Take the square root of both sides, so you're going to get x minus 2, because now these cancel, equals the square root of 9. I'm going to leave it as a square root of 9, because you have to remember that you're going to have a positive or a negative version. So the positive version would be x minus 2 equaling, positive 3. That's one value. Or x minus 2 equaling negative 3. So then solve, bring the 2 over. X equals 3 plus 2. So x equals 5. That is one solution. And then bring the 2 over here. X equals minus 3 plus 2. X equals minus 1. And there you go. So pretty quick. Again, that was just using vertex form, right? Solving roots in vertex form. C. Well, this looks pretty tough. This is neither in factored form or a standard form. All right, because first off, none of the side is set to 0, okay? We know we need to have it equal to 0 on one side. So let's do that. Let's first bring this over here. Remember, this is actually all one big term. This is all being multiplied by itself. So this becomes x plus 1, 2x minus 3, and then bringing that over becomes minus 2 x plus 4 equals 0. Okay, now we have it set to 0. But this is neither standard nor factored, and we know it's not factored because you have this negative here. Factors need to all be multiplied. All your brackets need to be multiplied between each other. So we need to get this into one form. So let's put it into standard form. Let's expand this out. So if we expand out this bracket right here, all right, do your foiling. So take this term, multiply it in, do the same thing for the 1 into this term, into this term. Okay, if you do that, you'll get 2x squared minus 6x plus 2x minus 3. And then expand this negative 2 in here to both of these. You'll get minus 2x minus 8. And again, that's still all equals 0. Collect your like terms. So we have 2x squared. This 2x and this 2x cancel. So minus 6x minus 8 equals 0. All right, so now you're like, do I use quadratic formula? Do I use factoring? Like, what is the best method to go about solving this? And it might not always be easy. So again, you could use quadratic, but with practice, you might see, oh, well, I can look at this and I might be able to turn this into a simple trinomial and factor. So I'm going to take this 2 out here and here, and let's see what happens. X squared minus 3x minus 4. Well, factoring that is now a simple trinomial. You get 2 numbers that multiply to negative 4 and add up to negative 3, x minus 4, x plus 1. So there's your factors. So your zeros, you solving it, is when you're taking your first bracket, this one right here, x minus 4, setting that to 0. So x equals 4 is a solution. And then your other bracket, which was x plus 1, set that to 0. So you get another solution of x negative 1. So you could have used quadratic formula there and solved, but again, factoring is definitely the way to go if it's possible. But now, let's look at example 4. The profit on a school drama play is modeled by the equation P of x equals negative 60x plus 790 minus 1,000, where P of x is the profit in dollars and x is the price of the ticket in dollars. What is the break-even price for the tickets? Okay, so again, this whole break-even price means you're trying to find when P of x is 0. So if you're given a P of x equation, so if P of x is minus 60 x squared plus 790 x minus 1,000, well, and you want to set this to 0, so 0 equals all of that, can you factor this? Is this a simple trinomial? Is this a complex one? Is it perfect square, right? So in doing this, it takes a lot of work, a lot of math. These are big numbers. And at this point, ask yourself, is it more efficient for me to sit here and try and factor this? Or would it be more efficient for me to just use the quadratic formula? And why is this a quadratic formula question? Because again, you're asking for when P of x is 0. So essentially you're taking a quadratic equation and you're setting it equal to 0. So you are solving this. So in solving this, we can solve it using quadratic formula. So the variable of question when we are setting this to 0 is x. So this would be x equals, and it's negative b plus or minus b squared minus 4ac all over 2a. So this will be a calculator question. All right, let's plug in all our values. So remember, this is a, this is b, and this is c. So just plug in where you see the variables. So we have x equals, well, negative b, so in this case that's minus 790 because it's negative b and b is positive 790, plus or minus 790 squared minus 4, our a is minus 60, and our c is minus 1,000. All of that is all over 2 times your a value, minus 60. Okay, so x equals, and actually no, I'll solve it over here. Give myself some room. X equals minus 790 out front, plus or minus, let's clean up that square root. So 790 squared is 624 100. And then minus 4 times 60 times 1,000. So it will be a negative number because it's 3 negatives all being multiplied. So 4 times 60 times 1,000 minus 240,000 all over 2 times 60 is minus 120. Okay, x equals minus 790 plus or minus the square root. Clean up that square root. So 624 100 minus 240,000 is 384 100 all over minus 120. So square root of that answer, it's not a nice number. You'll get 790 plus or minus, okay? This plus or minus right here is what gives you the possibility of having either 2, 1, or 0 solutions, right? Or 0. So we're plus or minusing, and taking the square root of 384,100 gives us 619.76. 2 decimal places is enough. All over minus 120. So now, in the quadratic formula, you have to do one scenario where you're dealing with the positive. So you'll have one solution where x equals 790 and then the plus the square root, 619.76, all over minus 120. And then you have the other one, which would be x equals minus 790, and in this case, minus 619.76, all over minus 120. So use your calculator. So in this first one over here, minus 790 plus 619.76, divide that by negative 120, you're going to get 1.42. And then over here, x equals minus 790 minus 619.76. Divide that by negative 120, and you get 11.75. So what does that mean? What do these solutions, these are solutions, these are your x-intercepts. Actually, I should write x equals. Well, in the context of this problem right here, x is the price of the ticket in dollars. What is the break-even price of tickets? Well, you have two break-even points. You can either sell tickets for $1.42 or sell them for $11.75. Right? So what is the break-even price of tickets? Well, the break-even price for tickets is $1.42 or $1.75, because that will give you a profit, a P of X, of 0. Okay. So at what price should the drama department set the tickets to maximize the profit? What is the maximum profit? All right, so again, whenever in quadratics you see this word maximum, just brain has to go, I'm looking for the vertex. All right, well, we're going to apply the formula we learned before, where a vertex has both a h and a k. Well, we can calculate our h value. All right, the vertex, the x-coordinate of the vertex is taking your two zeros, x plus 1, x2, and dividing them by 2. It's finding the halfway point. So h would be, in this case, we had one value being 1.42, and we had the other one being 11.75. Take those, divide it by 2, you'll get an h value of 1.42 plus 11.75, divide that by 2, and that's $6, right? Or, yeah, so $6, I'll just put the number, 6.59. Okay? And then the K value, because it asks for what is the maximum profit, so, well, it's asking for what the price is and the maximum profit, so this is one answer right here. Because your vertex in the context of this problem, this right here, the x value are your prices, because it's measuring x's, and this right here is your profit. That's what this is measuring. This is P of x. Okay, so if we have h, we'll just plug the h value into your profit equation. So we have our profit equation, which is P of x equals minus 60x squared plus 790x minus 1,000. So I'm looking for the profit when my h value, add my h value, because at my h I'll be able to get the k, 6.59. So minus 60, 6.59 squared plus 790, 6.59 minus 1,000, and again, use your calculator here. So definitely cannot do this in your head. So I will use mine. So 6.59 square that, times that by negative 60. And my calculator is giving me an answer of 1,600.41. And again, that is profit, so this would have units of dollars, just like this would have units of dollars. So answering this problem, therefore, the max profit is $1,641 when tickets are sold for $6.59. And there we go. That concludes today's lesson.